Well, welcome back. We're winding down to that end of the year. We've got a nice video on factoring for you, specifically factoring by grouping, and I threw a nasty trig one in there at the end. So take your time, and we look forward to seeing you tomorrow. So the first problem we're going to attack is factor by grouping. And my hint for remembering factor by grouping is to notice that there are 4 terms, and typically we solve it by using 3 GCFs. So let's go ahead and dive into a few examples. So first and foremost, it just says factor. So don't go too far, just factor. Alright, so you'll notice I have my 4 terms, and I'm going to say 3 GCFs. So I'm just going to kind of group the first 2, and ask myself, what do those 2 have in common? What is the GCF? And hopefully you're saying you can pull out an x squared, and then in parentheses write what's left. I would say 3x minus 5. Okay, so that was 1 GCF. So I'm going to put first here, that was my first GCF. Now I'm going to do the same thing, and I'm going to try to get a GCF out of these 2. Now, if you're thinking, you're running through numbers in your head, 2, 4, 6, 8, think about this. We want this to be the exact same thing we have left over here. Okay, so if you ever get stuck, I just kind of say, well, if I have 8 and I want a 5, 8 divided by 5 is 16, so I'm going to pull out a 16. Now, do I want a positive 16 or a negative 16? Well, if this is a positive 80 and I want a negative 5 left over, I have to pull out a negative 16. And when I do that, negative 48 divided by negative 16 is 3x, and positive 80 divided by negative 16 is negative 5. So that was my second GCF. Okay, so we're not done there. Remember, we said 3 GCFs. That was 1, 2, and now I have to find a third GCF. Now, box this front in and this back end in. You are looking at those 2 sections that we have in brackets here and asking yourself, what's the GCF? What does this bracket have in common with this bracket? I would say they both have the 3x minus 5. So again, I'm pulling that out as a GCF. Now if I take that out, on this side I have x squared, and on this side I have minus 16. Okay, so I just want to make a note that that was my third GCF. Now, the directions did only say factor, so my last thing I have to check is whether I'm factored completely. Can I factor 3x minus 5? Nope, so I'm just going to rewrite it. But can I factor x squared minus 16? I would say definitely. That's a difference of 2 squares, so x plus 4 and x minus 4. And lastly, I'm just going to put a little FC there because I am officially factored completely. Notice I'm not teeing it up and solving it. I was just factoring. Alright, so next one, factor completely. Why don't you pause it, try it on your own, pull out your 3 GCFs, and then I'll walk you through and see if we get the same thing. Pause it, don't cheat yourself. So you can see what my first and second GCFs were. I did 2. Now again, make one big bracket under each side and ask yourself, what is the GCF? What is that third and final GCF? Well, I would say I could pull out the x plus 3. And as I do that, I'm left with an x squared minus 4. And again, I just want to make sure I'm factored completely. I think I have a difference of 2 perfect squares again. So I've got x plus 2, x minus 2, and a little FC for factored completely. So I think these are fairly simple problems. Just keep saying to yourself you need 3 GCFs. Alright, in our next example, you'll notice the wording's just a tad different, and just highlight that word solve, or box that in, make note of that on your paper. This time, and you'll notice it said equal to 0 this time. This time, you want answers that say x equals. You're going to go beyond factoring and actually solve. So again, why don't you pause it, try it on your own, just make sure we can factor completely on the same page here, and then we'll tee it up and solve. So I'll fill you in on my first step there. I pulled out a 4x squared, and again, be careful, this term didn't disappear, it turned into a 1. And then I pulled out a negative 9, and again I've got 2x plus 1. Remember, these 2 should match if you did it correctly. Okay, so now I bracket the left side and right side, and I'm looking for a GCF. I can pull out the 2x plus 1. And when I do that, I'm left with 4x squared minus 9. Now again, before I solve, and this is still equal to 0, I want to make sure I'm factored completely. So I've got 2x plus 1. Again, this can get factored again. We have difference of two squares. 2x minus 3 and 2x plus 3 equals 0. Now I can officially tee it up between all those pieces that are being multiplied and set each piece equal to 0. And as you do that, we can quickly solve for x, and hopefully you're getting the same thing I am. I've got x equals a negative 1/2, a positive 3/2, and a negative 3/2. And there you have it. So when it says solve, you're going to go one step further and actually tee it up once you are factored completely. All right, one last factor by grouping. Let's go ahead, pause it, try it on your own, see if we get the same numbers, and then compare to mine. So one key thing I want to stress here is that notice I pulled out a 6, but make sure you put that plus sign in there. There has to be a sign there, whether you pulled out a positive or negative. This is huge that you have a sign here. You will lose a point if we don't see that on your test paper. So that was 2 GCFs going for my third now. Hopefully you can pull out the x minus 3. And I'm left with x squared plus 6 equals 0. Now, at this point, can you factor again, or are you factored completely? Is this a difference of two perfect squares? Well, first of all, it's not even a difference, it's a plus sign, and 6 isn't a perfect square. So I'm going to make a little note, I am factored completely, and at this point I can just tee her up and solve each side. So set each one equal to 0. Here I get x equals 3. I get x squared plus 6 equals 0. So if I keep chugging, I get x squared equals negative 6. And I'm going to take the square root of each side. Now don't forget the most important thing there is that I should get plus or minus the square root of negative 6. Now that's not simplified. I can go one step further. Hopefully we remember that a negative under a radical turns into the letter I for imaginary number, radical 6. And I can't break 6 down. Clearly 3 and 2 can't break down. Notice where that I is, it's to the right of my plus minus. This plus minus should be out front. So you do actually have 3 answers. I have 3, I have positive I radical 6, and negative I radical 6. And lastly, I just want to confirm that by me saying x to the third, that is implying I should get 3 answers. That larger exponent of 3 is telling me those 3 answers. All right, we've got one more factoring type question for you here. You'll notice it says, what is the solution of this equation? Now, it's not factor by grouping because I don't have 4 terms. And that's okay. We're just going to work on our factoring and solving. Solution set clearly means solve. From the word solve, we are finding the solution. So let's start with the type of factoring we see first. Hopefully the word GCF is screaming out at you. 3 and 48, I can pull out a 3. X to the 5th and x, I can pull out an x. So I'm left with an x to the 4th minus 16. I think you would agree. Now, again, I don't think I'm factored completely yet, so I don't want to finish there. Difference of two perfect squares. Clearly I have the difference. 16 is a perfect square. X to the 4th is a perfect square. Okay. So why is x to the 4th a perfect square? What times what gets you x to the 4th? Well, x squared and x squared. And then I'll get my plus 4 and my minus 4. Now, ask yourself again, are you factored completely yet? Well, that is, this is a difference, again, of two perfect squares, so that can get factored. This one, however, tricks a few people. This is not a difference of two perfect squares. Although they're perfect squares, we don't have that difference. So this bear does not get touched. And this one becomes x plus 2 and x minus 2. Okay, now we did say solve, and I just want to take note. Look at that exponent of our equation. X to the 5th. That's implying I should have 5 solutions. So set each term equal to 0. And we'll go ahead and solve each one. If I divide by 3, I get x equals 0. I'm going to solve these easy ones. Here I'm going to add 2, I get x equals 2. Here I'll subtract 2, I get x equals negative 2. Now on this guy, I'm going to have to say x squared equals negative 4. I'm going to have to take the square root of both sides. And don't forget, when you put your own square root in there, you're going to put plus and minus. The negative turns into an I, and the 4 turns into a 2. So obviously you can say plus or minus 2I or I2, doesn't matter. 2 typically comes first to be mathematically correct. And I should get 5 answers. So I've got my 0, I've got my plus 2I, I've got my minus 2I, my negative 2, and my positive 2, for a total of 5 answers. Alright, well, I actually have one more factor by grouping. I just thought of this question and I thought it was pretty neat, so I thought we would do one more together. This time the factor by grouping was with trig functions, which makes it even more exciting. So, it's a little sloppy, let me read it to you. Sine squared x cos x minus 2 sine squared x minus cos x plus 2 equals 0. So it's clearly going to work the same way. Box those first two in and tell me what you think that GCF is. Hopefully you're saying this side and this side have a sine squared x. If I were to remove that, I'd be left with cos x and a minus 2. Okay, notice I'm not touching this number 2 at all. I'm just removing the sine squared, the two things that match. All right, let's box this side in. They have to have something in common. Well, if you don't see, a specific, 4, 6, 8 sine, cosine, x, basically you can always pull out the number 1 or negative 1. Now, if I want it to be cos x minus 2, I'm going to pull out a negative 1, and I'll be left with positive cos x minus 2 equals 0. So don't forget you can always pull out a positive or a negative 1. So those were my two GCFs. Now let's box the left side in and the right side in. What is my third GCF? What does this bracket and this bracket have in common? Hopefully you're saying cos x minus 2. And then the quantity that I would have left would be sine squared x minus 1. Pretty neat to use trig functions. Alright, now I'm not factored completely yet because I have difference of two perfect squares here. There's my difference, and clearly these are perfect squares. So I've got cos x minus 2. Okay, how do I factor this? Well, I would just say sine x plus 1 and sine x minus 1. Just like if this was a plain old x squared, I'd say x plus 1, x minus 1. Okay, now we've gotten to the nice easy point. We're just going to tee these suckers up. Go ahead and set each one equal to 0, and we'll continue to solve. So on this first term, I get cos x equals 2. Well, you can try, obviously you want to take the inverse of both sides, but let's just use some common sense. Here's my cosine graph. How many times does that cosine graph equal 2? Well, remember, it only has an amplitude of 1. It goes up to positive 1, down to negative 1, so clearly this side is a does not exist. On this side, I'm going to get sine x equals negative 1. And again, those 1s and 0s, I'm going to draw my graph out. How many times do you have an answer of negative 1? Well, I would say once, and if I put my tick marks in, I should say that is at x equals 3 pi over 2. And on this one, I've got sine x equals positive 1, and I'm just going to refer back to this graph I drew over here. How many times does this curve hit positive 1? I would say once, and that's at x equals pi over 2. So I've got myself two answers, pi over 2 and 3 pi over 2. And again, if I just quickly verify at the top there, my largest exponent was a 2, so in fact I should get two answers. Well, that does it for us tonight. We look forward to seeing you tomorrow. Have a great night.